A podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Welcome to another episode of the Reliability Matters podcast. Where am I? I am clearly not in my normal studio. I am in sunny Southern California in Anaheim at the IPC Apex Expo, and I am doing a series of little mini Reliability Matters episodes, 10 or 15 minutes long each, with various subject matter experts, and we'll talk about the products that are showing at Apex, and more importantly, even at least to me and my audience, how those products work in the field of reliability, how they impact reliability in the various fields of electronic assembly. So first of all, I also want to thank Trevor Galbraith from Global SMT and his amazing Summer, who is sitting right over there, pushing the right buttons, trying to make us look and sound as good as we can ever look or sound. And Jen, her able-bodied assistant, who's also making sure that I don't fall out of the frame of the camera and all of that stuff. So thank you, all of you, for making the show look terrific. Gus Mavro, Regional Sales Manager for Seho, welcome.
Thank you. It's a pleasure to be here.
Well, I'm glad you're here. You and I have met before, but it normally involves some kind of alcoholic drink, and we probably can't even talk about what we've talked about before, right? So what happens at trade shows stays at trade shows. But I want to kind of set up the question. When considering the topic of automated inspection systems for electronic assembly, reliability is a critical factor to assess, given its direct impact on production quality, efficiency, and operational costs. With that general statement being said, automation inspection systems are crucial, as I said. How do AOI systems in general, and I think this is probably a good softball question for you, because I think you know the answer to it. I think I know. I think probably my audience knows. But for the few people in my audience that may come from another industry and aren't really sure, AOI, automated optical inspection, what role does it play in the inspection process? Where in the assembly process is it employed? And what are the benefits of, or how does it best impact reliability?
Initially, it was, after the process was done, we would inspect what we made and hope that everything went well. Over time, it's transitioned now that we're doing pre-solder inspection. And for Seho, our inspection only is for through-hole, for wave solder and selective soldering systems. And about 10 years ago, when we first started putting our own AOI systems into a selective soldering cabinet to look at the solder joint after we made it. Since then, we've branched out into full standalone AOI systems that can do both component inspection before the process and solder and joint inspection after the process.
And doesn't Seho also make soldering machines, wave solder machines?
Yes, we did. This is
okay.
We still do. We haven't changed our focus, but the idea was to present to a customer, I hate this phrase, the total solution.
Right. But, I hear you. Yeah, but in this case, it's a relevant statement, right?
In this case, it works well because it's done right after the soldering process. So it made sense then to branch into it and just branching in from a camera and a selective soldering system. Then we said, well, we'll make the box so that we can do it for wave and other through-hole applications.
Right.
And from there, you've seen the box with the standalone AOI system.
Yeah, Summer, let's throw up that picture too of the, this is one of your AOI systems.
Yes.
And when I think of an AOI system, without any branding, that's kind of what they look like to me.
Yes.
They're boxes that are pretty well contained. Boards come in on one end of the machine, come out the other end of the machine on a conveyor. There's camera systems. Can you run that video real quick there, Summer? There's camera systems that are moving around, taking all these pictures from multiple angles, whatever the case may be, and analyzing that,
yes,
crunching the data, giving a report to the operator. Let's go back to picture one. summer. You guys, when I say, we talk about popular sayings that are overused, thinking outside the box. You guys literally thought outside the box. There's no box. This is your latest AOI machine, and it's not contained. It doesn't look like an AOI machine.
This is, all the inspection has been after the process. This is inspection before the process to stop creating a defective product. Boards are very expensive, and you put a component in the wrong location or in the wrong orientation, and that could board could be scrapped based on you can't fix what you've done. So from this, what we've done here is taken that technology and put it in the front. And from here, we take a picture of a golden board, and then from that, before it goes either into a wave or a selective soldering system, it compares the orientation of all the components. It can read the top of the components, so if the components are all the same color but have different part numbers, or from that standpoint, we can differentiate those, and we can stop from putting a bad board into the system.
So this is after printing, before reflow?
This would be after the reflow process for through hole. For through hole.
Through hole, okay.
So
there's a difference.
You've created this expensive board for through hole, and now you have to add some capacitors or some connectors or something.
So you want to make sure before you go to the surface mount process that
this is
you
after
can fix the through hole stuff.
This is after the. This could be after the surface. This is after the surface mount process.
Oh, wow. Okay.
And you now have some through hole you want to do on a selective process, for example. So this is checking to make sure that the orientation of the components are as they should, and it will detect it and will keep the operator from moving it along in the conveyor. It'll identify the wrong components, and it won't let the conveyor activate to go forward if you have an inline system, or if it's a manual system where you're just doing a final inspection on the board before it goes into a magazine, which then would go into some type of a selective or wave system.
Excellent.
Again, this is all to maximize the customer's ability to not rework as much as possible, to save them money so that they can,
Fix
make
it
a better
in the
product.
factory. Don't fix it in the field.
Yes.
Right. Fix it in the factory, or better yet, prevent the problem from even occurring in the factory. Right. Well, Gus, Mavro, thank you so much. We're almost through day one of the show, and we've got tomorrow and Thursday to go. So I know you want to sit here forever and take a load off your feet, but it is time to go back to the booth and start selling boxes.
Hey, I appreciate the time. Thank you very much.
My pleasure, Gus.
Nice talking with you.
Good seeing you again. We'll see you probably tonight out there somewhere.
Oh, yes.
The Arch FX manufacturing platform, processing over 1 trillion data points each month, bringing value to every level of your organization. That's manufacturing insights for tomorrow.
Imagine the competitive advantages of producing high-mix and high-volume PCB assembly on a single SMT line, running non-stop even during changeovers. It's available now from the only maker in the world providing mixed production SMT line solutions complete with full dual printing, SPI, pick and place, reflow, AOI and board handling machinery for different product dual lane processing in the smallest footprint possible. Make more PCB assemblies with less time, less space, less investment. At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
Welcome back. I'm glad you came back. We are now talking to Mark Stansfield, Managing Director of SolderStar. How are you?
I'm good, thank you. Thanks for
Good.
inviting me.
I know you had that look like you need to get off your feet. So
I certainly do.
Here we are, yes. Your company makes profiling equipment, oven profiling equipment.
That's correct, yeah.
That is a little different than what I would consider a stereotypical profiler. But before we get into that difference, I just want to establish that one of the things, which is part of the difference that your product can do, besides normal profiling things, is measure nitrogen levels. So before we just talk about that, explain to me and my audience why in a reflow oven people are inerting it with nitrogen. Why do they do that? What benefit does that provide? And then we'll get into kind of the tech on how
we do it.
The value of monitoring it.
Yeah,
right?
of course.
Let's tell us why it's there in the first place.
Yeah, well, there's a number of reasons to use nitrogen. The main one really is we're looking to reduce the amount of oxidization in the process. Whenever you've got heat and metals in the same place, then inevitably there will be some level of oxidization. Now, we're not actually removing the oxidization, that's the job of the fluxes within the solder paste. But what we can do is, by inerting the process and reducing the concentration of oxygen there, we can actually slow down any oxidization or certainly minimize it, which is a big benefit. The second reason is we improve wetting, so we get nicely soldered joints.
So in a wave solder machine, for example, maybe less bridging?
Yeah, certainly.
Does it play with, surface tension may not be the right
No, that is the right
term. In that
yeah.
context also? Okay. Does it lower the surface tension?
It does indeed, yes.
Yeah.
Which leads to other problems actually. It's not just
solve
the
one
lower
problem, get
yeah,
another.
It's
Yes.
not the lower the PPM the better. That's not the case, because if we go too low, then in reflow we get problems with tombstoning and things like that. So it's important we get the level right. You know, we save money by not driving too much nitrogen in there and having too high a flow rate.
Great. You just gave me a good segue. Now
Yeah.
we understand why people are using nitrogen, the benefits of it,
Yep.
and what happens if you don't use it in the right in the right volumes or in the right concentrations or whatever. So nitrogen is measured in a machine in like a part per million ppm standard, and there are different ppm availabilities of nitrogen. If you're generating your own nitrogen, that may be adjustable. If you're buying nitrogen, delivered in a big tank, maybe you just predetermine what the ppm is. I'm not sure if it changes as it's delivered, but you need to get it right. Now, profilers historically, my understanding of profilers historically are just measuring, they're thermocouples. They're just fancy thermocouples, lots of them in various places of the board. And then there's algorithms that can track predictions and ramps and all this stuff. You end up seeing this pretty cool graphic chart of the temperature. you're adding a different dimension to that. You're adding the ability to measure O2.
Yep.
Why hasn't that been done sooner? First of all, I'm not going to put blame on everyone else. Why didn't you guys do it sooner?
Yep.
Why hasn't the industry really embraced it sooner? Is the tech like so new that you've discovered a way to do it and package it to be able to have that kind of sensor in an extremely hot environment? Or
Yeah.
what were the challenges
reasons,
there?
yeah. It's quite a difficult thing to do, actually. It's actually the culmination of a 3-year development program. We measure thermocouples, of course. That's core to every thermal process is the need to measure temperature. But we embarked 3 years ago on the development of a new data logger, which we call the SolarStar SLX. The X stands for expandability, and what this allows us to do, it gives us the performance and communication methods to add advanced sensors to it. So not just temperature, we can measure vibration on the conveyor, we can measure vacuum levels in the vacuum chambers that you'll see now on some reflow processes, and then the final piece in the jigsaw was the ppm level for people who are using nitrogen. And we've been asked numerous times over the years, and it has proved quite a labour of love to get there. But we are there now, and we've got basically a single pass instrument that can measure all those parameters, give the engineer instantly all the data he needs.
So someone may make a decision to purchase a product like yours just for the nitrogen measuring capability.
Possible.
Let's talk about the other stuff that's already in there, which is the ability to measure temperature and actual profile, thermal profile aboard. Are there any advancements in that realm as well? Has that product line as an industry matured to the point where pretty much all the profilers have very similar capacities and benefits
to
maybe
some extent, yes,
on the extreme edges?
To some extent. Usability is a key thing. Our new
user interface and
more the instruments, actually. People have said for many years it's all about the software, hardware's the same. I've heard that many times in the last 25 years.
That depends on which side of the factory they sit on.
Yeah, maybe. Our new data log is pretty neat. We don't need a computer to set it up. We're trying to streamline the whole process. You can just walk up to the machine, connect it to your fixture, detects all the sensors, all the thermocouples, shows the engineer if they're good or bad, because these things break from time to time, they're quite fragile. And then you can just press the button and go through the machine. So there's no apps, there's no need for a computer. We just want to get data from the machine as quickly as possible. Of course, we still download to a computer. We still need to do that to make the analysis. We've got some pretty nice tools. We have integrated SPC, because there's two functions for these devices. One is the setup and optimization of the process. But once that's performed, many of our customers want to do daily checking of the process, or when there's a batch change to different PCBs. So they have some real nice historical data to do SPC trend analysis and things like that. Yeah.
Right. Excellent. And is this oven, the O2 sensor, not something that's already in reflow ovens from the factory, or is it already there but you're doing it better, or you're combining other value addeds with it, or is it missing from the equation altogether, largely?
No, most machines have a single point of measurement at one point in the machine.
Okay, which may not be representative of certain areas.
We specialize in measuring at product level. That's
as it travels through.
Same with the temperature, same with the O2.
That makes sense.
And there's many reasons why it goes wrong. It shows quite a few things, actually. Different machines have different nitrogen designs. Some are feeding in from a single point, the nitrogen. Some are feeding in from both ends of the machine. And you pass the shuttle through, you'll see immediately the benefits of both of those designs. There's lots of seals that degrade. So when the ppm's not right, it's really difficult to find out where that problem is. It's expensive to maintain those machines. And you've got to change every seal.
All you know is it's not right here. You don't know where the offending area is.
Yeah, the key difference is we're measuring zone by zone, so we see exactly where in the machine any problem may lie.
It goes through zone 4 and spikes or dips, then you know
it's a big time saver.
Something around there. Yeah. Excellent. And has it been received well so far?
Extremely well, yeah.
Good.
Yeah.
Well, Mark Stansfield, thank you for being my very short time guest today on this abbreviated version of Reliability Matters, a little tapas bar of subject matter experts. Thanks for being here, and I wish you all the luck in the world, and you probably don't need the luck, but good success to you on this new product launch.
Okay, thank you.
Take care.
And you.
For micro dispensing, there is one product line that is proven and trusted by manufacturers in semiconductor packaging, electronics assembly, medical device, and electromechanical assembly the world over. DL Technology, superior pumps and needles for the finer things in.
Without reliability, with reliability. A world of difference. Welcome on the journey to better reliability outcomes.
The Arch FX manufacturing platform. Processing over 1 trillion data points each month. Bringing value to every level of your organization. That's manufacturing insights for tomorrow.
Imagine the competitive advantages of producing high mix and high volume PCB assembly on a single SMT line, running non-stop even during changeovers. It's available now from the only maker in the world providing mixed production SMT line solutions complete with full dual printing, SPI, pick and place, reflow, AOI and board handling machinery for different product dual lane processing in the smallest footprint possible. Make more PCB assemblies with less time, less space, less investment. At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
Why do something 3 times when you can do it only once? Using N1 Pass technology, BTU's new Profile Tracer is a next-generation thermal profiling tool, providing real-time data acquisition for oven optimization. It identifies inconsistencies due to temperature variables at both the product level and the heat source. Profile Tracer measures dual temperature locations as well as vibration, all in one pass, giving you time to attend the more important things in life.
For micro dispensing, there is one product line that is proven and trusted by manufacturers in semiconductor packaging, electronics assembly, medical device, and electromechanical assembly the world over. DL Technology, superior pumps and needles for the finer things in
Without reliability, with reliability. A world of difference. Welcome on the journey to better reliability outcomes.
The Arch FX manufacturing platform. Processing over 1 trillion data points each month. Bringing value to every level of your organization. That's manufacturing insights for tomorrow.
Imagine the competitive advantages of producing high mix and high volume PCB assembly on a single SMT line running non-stop even during changeovers. It's available now from the only maker in the world providing mixed production SMT line solutions complete with full dual printing, SPI, pick and place, reflow, AOI and board handling machinery for different product dual lane processing in the smallest footprint possible. Make more PCB assemblies with less time, less space, less investment. At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
Why do something 3 times when you can do it only once? Using N1 Pass technology, BTU's new Profile Tracer is a next-generation thermal profiling tool, providing real-time data acquisition for oven optimization. It identifies inconsistencies due to temperature variables at both the product level and the heat source. Profile Tracer measures dual temperature locations as well as vibration, all in one pass, giving you time to attend the more important things in life.
For micro dispensing, there is one product line that is proven and trusted by manufacturers in semiconductor packaging, electronics assembly, medical device, and electromechanical assembly the world over. DL Technology, superior pumps and needles for the finer things in
Without reliability, with reliability. A world of difference. Welcome on the journey to better reliability outcomes.
The Arch FX manufacturing platform. Processing over 1 trillion data points each month. Bringing value to every level of your organization. That's manufacturing insights for tomorrow.
Imagine the competitive advantages of producing high mix and high volume PCB assembly on a single SMT line running non-stop even during changeovers. It's available now from the only maker in the world providing mixed production SMT line solutions complete with full dual printing, SPI, pick and place, reflow, AOI and board handling machinery for different product dual lane processing in the smallest footprint possible. Make more PCB assemblies with less time, less space, less investment. At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
Why do something 3 times when you can do it only once? Using N1 Pass technology, BTU's new Profile Tracer is a next-generation thermal profiling tool, providing real-time data acquisition for oven optimization. It identifies inconsistencies due to temperature variables at both the product level and the heat source. Profile Tracer measures dual temperature locations as well as vibration, all in one pass, giving you time to attend the more important things in life.
For micro dispensing, there is one product line that is proven and trusted by manufacturers in semiconductor packaging, electronics assembly, medical device, and electromechanical assembly the world over. DL Technology, superior pumps and needles for the finer things in
Without reliability, with reliability. A world of difference. Welcome on the journey to better reliability outcomes.
The Arch FX manufacturing platform. Processing over 1 trillion data points each month. Bringing value to every level of your organization. That's manufacturing insights for tomorrow.
Imagine the competitive advantages of producing high mix and high volume PCB assembly on a single SMT line, running non-stop even during changeovers. It's available now from the only maker in the world providing mixed production SMT line solutions complete with full dual printing, SPI, pick and place, reflow, AOI and board handling machinery for different product dual lane processing in the smallest footprint possible. Make more PCB assemblies with less time, less space, less investment. At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
Why do something 3 times when you can do it only once? Using N1 Pass technology, BTU's new Profile Tracer is a next-generation thermal profiling tool, providing real-time data acquisition for oven optimization. It identifies inconsistencies due to temperature variables at both the product level and the heat source. Profile Tracer measures dual temperature locations as well as vibration, all in one pass, giving you time to attend the more important things in life.
For micro-dispensing, there is one product line that is proven and trusted by manufacturers in semiconductor packaging, electronics assembly, medical device, and electromechanical assembly the world over. DL Technology. Superior pumps and needles for the finer things in
Without reliability, with reliability. A world of difference. Welcome on the journey to better reliability outcomes.
The Arch FX manufacturing platform. Processing over 1 trillion data points each month. Bringing value to every level of your organization. That's manufacturing insights for tomorrow.
Welcome back for our final segment for today's installment of the Reliability Matters podcast. In case you jumped on a little bit late, I'm Mike Konrad. I'm the host of the Reliability Matters podcast, and I'm interloping into the Global SMT booth. Thanks to Trevor Galbraith for loaning me his studio, and Summer and Jen for pushing all the right buttons at the right time and making this go off as seemingly easy as possible. My guest on this final segment is Jesper Leike from Viscom.
Thank you.
The CEO of Viscom, or
Indeed.
the Intergalactic
For
head
Viscom
honcho,
Inc. anyway, yes.
Or as they say in Spanish, El Jefe. Right?
Exactly.
Yeah, the big boss. You're introducing an inspection system here at the show called the iX 7059. Kind of sounds
Correct.
like a BMW.
Yeah. Make it interesting,
There
right?
you go. And you're going to, one of the acronyms that came up is One Next Generation AXI. I don't know what AXI means, so let's start with, tell me what
Basics.
AXI means, just
Sure.
so I'm there.
Yeah. So AXI is Automated X-ray Inspection. Short and simple.
That was
Very
too easy.
simple, right?
I was overthinking that.
Exactly.
Okay,
Don't
automated
overthink it.
X-ray
We
inspection.
try to keep it simple always, but it doesn't always happen.
Doesn't
that way.
always
But
work.
yeah,
You get
no,
people like
exactly.
me that try and make more out of
I
it
know,
than
exactly.
possible. Now, that was a good segue because I want to talk about X-ray. I have a theory about X-ray, by
Sure.
the way. When BGAs first came out on the scene, there was really not a lot of need before that for X-ray within our space, because we could basically,
Indeed.
with fancy lenses, we could oblique angle viewers, we could look under
Sure.
a part,
Yep.
and
Yep.
the clearances were so large, relatively speaking,
Easily done,
we
right?
could easily see it, right? Then BGAs come along, and we can maybe see 1 or 2 rows of balls in, and that's it.
That's it.
And suddenly, the makers of X-ray machine went, "Oh, we got
something.
we got something for
Exactly.
you." And I'm absolutely determined to believe that X-ray causes voiding, because we didn't have a void problem before we
Exactly.
we
That's
didn't
all
know we had a
X-ray's fault.
void
Exactly.
problem,
Yeah,
right?
no,
So
I agree. Totally.
Look what you've done, right? Look what you've done. You were the inconvenient truth. Like,
It's
okay,
the
if you're
inventor
gonna
of the
look,
BGA.
You're going to
That's
see.
what it is.
Exactly. So for my audience that may be a little on the peripheral of electronic assembly, how important, or let me ask this, what role does X-ray inspection play in the reliability of circuit assemblies? What is X-ray looking for that maybe more traditional optical-based systems can't look for?
Sure. I mean, the answer is very obvious. Obviously, that
can see
whatever
through things.
whatever you can see with your naked eye is optical inspection, and whatever you can see, such as BGAs, where you have hidden solder joints, you need X-ray, and that's the short version. So there are more than just BGAs, of course. There are all kinds of other components that's either shielded or they have other hidden solder joints. So you need some sort of visual on those that did you do it right? Of course, in your mind, yes, everything was perfect. I did it exactly after the book. But luckily for us, we're not always in that perfect world. There are some factors that will decide whether or not this is good or bad, or if you have some, you already mentioned voids or things like that. That's needed with X-ray. So you have to verify, even with a good process, you have to verify that your process is good at the end, and what your final product, that's the bottom line, of course, your final product needs to be top-notch before you deliver it to a customer. Otherwise, you won't be in business for very long.
Right. From a layman's standpoint, and I'll consider myself a layman in the X-ray world,
Sure.
there seems to be two technologies. One is to get the image
Yep.
with whatever clarity is
Sure.
required,
Yep.
and angles and things like that. The other is to interpret the image. And to me, I mean, there is an obvious magic of X-ray. You know, that's like a superpower, right?
Sure.
To be able to see
You can
through
see
things.
through things,
Right,
exactly.
But beyond
Superman,
that
yeah,
magic,
exactly.
we've had that magic for more than 100 years. So
Yep.
that part's not new. To me, even more impressive is the ability to discern, to interpret that through imaging. So not
Processing,
always
yeah.
what you're seeing on the screen is literally what the board looks like. It is a computer rendition of what the board looks like. How, when I remember many years ago, a friend of mine had to get some kind of MRI or something, and it produced an image. This was several years ago. And I saw a copy of the image. Like, it looks like the old days of over-the-air television stations when you weren't tuned to the television
Exactly.
station.
So
Just
what
like
am I looking
snow,
at again?
right.
Exactly, yeah.
And it took an MD that was a radiologist with extra years of training just to be able to pick out that slightly darker gray matter from
That nobody else can
no
see,
one else
right?
can see,
Exactly,
right? I mean,
yes.
you can stare at it all day long and you
Yep.
you never see it.
Yep.
That's been largely replaced now with computers, and I would assume with the use of artificial intelligence and other
Absolutely,
tech.
yes.
How important is it when you're choosing an X-ray machine to not only look at can it take the picture, but what it does after that?
Yeah.
What are the benchmarks that you would recommend people look for in determining the best machine type, brand, whatever
Sure.
to use?
Yeah. So I mean, that's many questions in one, but I'll
I know.
try
I
and,
tend to do
I'll
that.
try and
Yes.
answer
And you have
them.
8 seconds to answer it.
Oh,
No,
okay,
no.
there you go.
You're good.
No, of course. I mean, anybody can do take an X-ray image. It is, you already alluded to it. It has to do with resolution. It has to do with speed and flexibility. What can the machine do for you taking those images? The clarity is a main factor, of course. That, and then I would contradict myself a little bit. Clarity is just for the human eye, for the visual purpose of the human eye. We need to understand. That means we need to see it.
Yeah.
But then on to your second question is software. So the software really don't care. I mean, of course, it cares how it looks like, but it doesn't have to be so, let's say, crystal clear as the human eye would like it and the human brain would like it. But in fact, the software, and obviously assisted with AI, will take some of that guesswork from the MD that had 25 years of experience, where he could see this little blob in this image here that nobody else could look at. That's where the AI comes in. That is that 25 years experience, and it will point that out every single time because it's taught that way. So it has to
It's
do
a rule,
with
right.
yeah, exactly. Get an image, which anybody can do, and then it comes down to call it preference and capabilities of the software. What can you do with that image? And it needs to be interpreted with any software, obviously. The clarity is one thing, yes, but you need to look for, as you already mentioned as well, voids and things like that. And that's where the software comes in. So you need a machine that has, let's say, a good hardware to get the image, like a camera kind of thing. And then secondly, obviously, you need the software that can interpret that image and spit out as easy as possible, spit out that image and that result of that image to the human interface again, telling them, okay, this is a bad defect or a bad BGA because it has some voids in there, or bridges or whatever. and that's basically what you need at the end.
I know in the earlier days of processing, rendering a discernible image,
Sure.
it took time. It could take hours.
Oh, yeah.
Right? Has that been reduced? I mean, what is it? Where have we gone from, in terms of like a render time, if that's the right term, to where we are today?
Yep.
What's a typical time to produce an actionable image?
I mean, it used to be a coffee break. I'm 23 years with the company right now, so I mean, I saw some of the early days, and that was really start the process of generating a data gen, we refer to it as, so generating the program itself, compiling it, lack of better words. That took started, go for a coffee break, come back, it's still compiling, to now, I mean, we're talking seconds, milliseconds, really. So it's
near instant.
Night and day difference. I mean,
Wow.
obviously the computer power plays a huge role here. In some cases, you even have masters and slaves, so primary and secondary computers. So you have all the computer power you need. So let's say speed in that regards is absolutely no issue anymore. That's a thing from the past.
So AI requires training.
Yes.
I think the word AI is the wrong term. It's nothing artificial about it. I like to call it acquired intelligence.
Yeah.
Because it's not artificial. It acquired it from humans.
It does what
From
you ask it to.
Published works.
Exactly.
And all
yes.
that does everything. The problem with software is it does exactly what you tell it to
Exactly.
do. Right? Predictably.
Yes.
How are your programs,
Mm-hmm.
for example, updated to represent the latest package, the latest problem, the latest
Mm-hmm.
known defect? You know, tombstones came up at one point. You know, how to,
Sure.
you know, you had to learn
No,
that.
they didn't exist. Yeah,
Yeah, exactly. You know, voiding became a big issue. The volume of voiding has changed from specs. You know, there's been arguments over whether it's 1% or another. You know,
Sure.
one type of percentage or another percentage percentile. That's a defect. All that has to be learned by the machine, so it can flag a defect. Right?
Yep.
How does it learn? How does your company continue to teach these machines, and particularly maybe machines that are a few years old that maybe
Sure.
weren't around when whatever came out?
Yeah, no, exactly. So, I mean, we obviously, the obvious question is we always listen to our customers, of course. So whenever, let's say, call it some pioneer customers come to us and say, well, we have this new board, nobody knows it on the market yet, we're trying to inspect it, we need to make sure that these components, brand new components, nobody has seen, we want to introduce that to your machine and then see how can we make sure that after the fact that this is in fact catching the defects. And that's obviously step number one. Listen to your customers and figure out what makes sense.
Yeah.
And then obviously as well that we build up that data and collect images from those, call it studies and pioneer customers. And then we set up rules and AI generated support to help catching those defects that we have seen basically. So
Yeah. Well, very good. Well, that's about all we have time
Sure.
for. I know you want to sit here and stay off your feet for
Absolutely.
the rest of the afternoon,
Definitely.
but we do have to work, right?
I'll
You and
hang
I
out
both.
for another half hour. Yeah,
Have
exactly.
another, yes, and then it's happy hour somewhere. right?
Exactly.
So Jesper Leike from Viscom, CEO of Viscom, thank you very much for being my guest in this abbreviated TAPA-style version of Reliability Matters.
Sure.
For those of you who are watching Reliability Matters live, we'll see you tomorrow. I'll be back, as our old former governor used to say. I'll be back. And for those of you who are watching this on the Reliability Matters podcast, I'll see you in 2 weeks. Take care, everybody.
Thanks for having me.